Hello and welcome to the next lecture on earthquake resistant design of structures. In this lecture, we would be talking about the ductility features of structural elements meant for earthquake resistant design. We would be especially talking about the special confining reinforcement that's provided in the structural elements in order to build up the ductility. In the last lecture, we discussed about the ductility requirements of structural elements when we are designing it for earthquake resistance. In this lecture, we would be continuing with the ductility requirements for structural elements. Talking about the beams, in IS 456 2000 code, the splicing requirements are described for beams. In this code, it's mentioned that the splice length should be provided somewhere in the center of the beam and not at the corners or the joints or the supports of the beam. Further, it's also mentioned that it should be at least equal to the development length or 30 times the diameter of the largest longitudinal bar. Now, in case of splicing, which is to be done, there should be no splicing done after the bar diameter exceeds 36 mm. These are the requirements and the conditions mentioned in IS 456. Now, splicing here could be in the tension or compression zone. Mostly the splicing is provided only in the tension zone of the beam. Now, in case of ductile detailing code IS 13920 2016, the splicing is again mentioned to be equal to the development length LD or 30 times the diameter of the longitudinal bar. Now, not more than 50% of the bars should be spliced in the case of the longitudinal bars that are running throughout the beam. The distance from the supports in this code for splice length is mentioned to be greater than or equal to 2 times the effective depth of the beam, that's D. Now, 150 mm is the spacing of the transverse reinforcement or the stirrups that's provided in the zone of splice, whereas in the other portion it's greater than 150 mm. In relation to the beams, another criteria that has to be taken into account is the how the beam reinforcement runs into the columns. Now here there are columns at the two ends of this beam, and it can be seen that the beam reinforcement, both tension and compression, are running into the column. Now, the amount of anchorage that's provided at the ends is equal to the development length LD. The mode of anchorage is also vital here. Then, for a support, from the supports, for a length of 2D, where D is the depth of the effective depth of the beam, for this length, the reinforcement, the transverse reinforcement or the stirrups are closer, and the spacing of these is less or equal to D by 4 or 8 times dB, where dB is the longitudinal bar dia, and or 100 mm. Now, whichever of these is lesser. While as for the other distance, intermediate distance, where the spacing has to be maintained, the spacing of the transverse bars or the stirrups has to be maintained less or equal to D by 2. The end distance from the support, from the column support or the column face of the first stirrup is 50 mm at maximum. There is another criteria that is related to the columns. Now in IS 13920, it's mentioned that the columns should be greater than or equal to 300 mm in the side, or the depth or the width of the column should be at least equal to 300 mm. Another criteria mentioned here is that the it could be also equal to or greater than 20 times dB, where dB is the diameter of the bar, which is the longitudinal bar running throughout the length of the column. Now in columns, if the cross section is taken, it could be seen that the B by D ratio has to be greater than or equal to 0.45. Another criteria that has to be taken into account is that the tie or the rings or the transverse reinforcement has to be 10 mm bar dia for longitudinal bars greater than 32 or greater than or equal to 32 mm, while as it could be 8 mm dia of the transverse reinforcement for the longitudinal bars less than 32 mm. In case of circular columns, in case of the circular columns, the transverse reinforcement is to be provided such that it forms a ring. Now again here, the minimum bar dia of the transverse reinforcement has to be 8 mm in dia. Now all transverse reinforcements ends with a hook, and the hook length is 60 or it's greater than or equal to 65 mm. The number of bars in a circular column has to be at least 6 in as per IS 13920. Another feature given for ductile detailing of columns is the cross section and the patterns of the ties. Now the cross section being at least equal to 300 mm. Now if HC, which is the distance between the longitudinal bars, is less or equal to 300 mm, and BC, which is the width with the distance between along the width of the column between the longitudinal bars is less or equal to 300 mm, then a simple formation of ties is as given here. Now in case the overall length of the column is quite greater than 300 mm, but the width is almost equal to 300 mm, then HC, which is the distance between the longitudinal bars, if it's less than or equal to 300 mm, we could provide a bar, a central bar, a longitudinal bar, and in that case, apart from the hook ties, this form of hook tie or a cross tie is also to be provided. Now in other case, when both HC, both depth and the width of the column is quite large than 300 mm, then in that case there are many longitudinal bars being provided, and the cross ties are provided in this fashion. As per the detailings given in IS 13920-2016, now if a column beam facility is given to you, what we come to know is that under the action of lateral forces, there is a zone along which the plastic deformations are maximum, and the plastic deformations could be considered to be concentrated under those zones. Now that zone here is would be the location of the plastic hinge. Now these plastic hinges are the points of maximum plastic deformation under lateral loads, or they are also the points where plastic deformations are assumed to be concentrated. Now this could be replaced by plastic hinge length. Now what is a plastic hinge length? It is an area or a length over which the plastic deformations are assumed to be constant over the beam or the column surface. Now the plastic hinge length would depend upon various features, but it would be quite complicatedly dependent on the high concentration of compression strain around the section or maximum moment and the tension shift in the column section. Now why is this important, the plastic hinge length? The importance of the plastic hinge length arises from the condition that the concentration of plastic deformations in and around the joints could lead to the brittle failure of the joints. Now, in order to make the joints and its surroundings ductile, what is done is that a special confining zone is provided. Now here we can see that there is a column beam connection, two types, one at the top and the other at the bottom. At the bottom, the column beam connection is a continuous beam is running through the column. At the top, the beam is running into the column whereby it's a fixed support there. Now in the bottom portion one can see that there is a special confining zone from a distance of L0 from the face of the column to the beam as well as to the column on all sides. Now this zone L0 could be described as that zone which is the larger one of these. First, the larger lateral dimension of the member or the at the section where the yielding occurs. 2, h by 6 where h is the column height, the unsupported height or the clear span. Third is the or it could be 450 mm. Now whichever of these is smaller, that is the L0, not larger, it's the smaller one. Next is the spacing of the transverse reinforcement. Now in this zone, the special confining zone, the important criteria is that the spacing of the transverse bars is reduced. And what happens due to the reduction of the transverse reinforcement spacing is that the confinement increases. And once the confinement increases in that portion, the area around the joints becomes has more capacity to take compressive and tensile loads, and in that case the zone around the columns and the beams, which is specially confined, becomes more ductile. Now the spacing of transverse reinforcement would be smaller of these. First, 1/4 of the minimum member dimension of the column or beam. Second, 6 times the diameter of the smallest longitudinal reinforcement that's provided for the columns. Third, 100 mm link. Now whatever is the link dimension, it should be at least 100 mm. Another criteria associated with the special confining reinforcement mentioned in IS 13920 is the area of cross section of the bar. Now this is a circular steel reinforcing bar. It should be maximum of number 1, 0.09 into FCK by Fy into Ag by Ak minus 1 into Dk into Sv, or another one is 0.024 into SV into dk into fck by fy. Now, the larger of these two, that should be the area of the cross section of the circular bar that we take as in the special confining zone. This is the area of cross section of the special confining reinforcement. Now, what is AG? It's the gross area of cross section of the it's the gross area of cross section. AK is the core cross section, and then we have terms like SV and DK that will study ahead. So the terms SV is the spacing or the pitch of the links or the ties. HC is the longer dimension of rectangular link measured to the outer face. Now that's to be used here in this equation. ASH is the area of cross section of rectangular bar is maximum of 0.18 into FCK by Fy into Ag by Ak minus 1 into Hc into Sv, or 0.05 into Sv into Hc into Fck by Fy. Now Ag is the gross area of the column cross section. Ak is the area of the concrete core of column. Dk is the diameter of core of concrete column measured to outside of spiral link. Another feature is the special confining reinforcement that is provided into the footing of the column. Now this has to be at least equal to 300 mm, or it should be greater than 300 mm. So the special confining reinforcement is extended from the column base into the footing or the pedestal up till 300 mm into the footing. Now this ensures that the ductile zone or the special confining zone is extended well into the footing. Further, if the column is now connected to a shear wall, and in that case the column reinforcement is to be taken into the shear wall up till a length of equal to the development length of the bars. Now this whole column has to be specially confined. Now the reason for that is that this becomes a case of cantilever column, and in that case the whole of the column is under large plastic deformations. Thereby the whole of the column has to be specially confined.